Good morning. It's November 21st, and this is your daily brief in science. Here's everything you need to know. A volcanic eruption has erupted on the Reykjanes-Peninsula in southwest Iceland, marking the 7th eruption since December 2023. This event began late on November 20th and has resulted in a fissure approximately 3 kilometers long. However, experts estimate that this eruption is smaller than those that occurred earlier in 2024. While flights at Reykjanes-peninsula-erupts-again airport are operating normally and crucial infrastructure remains intact, the Blue Lagoon Resort took precautionary measures and evacuated its guests. Residents in the nearby area have also been forced to relocate for their safety, although officials maintain that there is no immediate threat to the town of Grindavik. Professor Magnus Tumi Gudmundsson, who is monitoring the situation, stated that while Grindavik is currently safe, the evolving nature of volcanic activity means that conditions could change. Approximately 50 houses have been evacuated by the Civil Protection Agency due to the threat posed by lava flows. Authorities have issued warnings regarding gas emissions that may affect parts of the Reykjanes Peninsula, particularly impacting the town of Grindavik, which has a population of about 3,800. This eruption came as somewhat of a surprise, with only minor seismic activity detected shortly before it began, unlike previous eruptions that had shown more significant warning signs. Benedikt Ofagsson from the Icelandic Meteorological Office noted that the current lava effusion is lower than in past eruptions and emphasized that there is no immediate threat to infrastructure. The eruption has produced stunning visuals, with bright yellow and orange lava shooting into the night sky, captivating viewers and generating significant attention on social media. Experts suggest that the Reykjanes Peninsula may continue to experience volcanic activity for decades or even centuries, given the region's geological characteristics. A significant breakthrough has emerged in the field of exoplanet research with the detection of IRAS-04125+2902b, recognized as the youngest planet ever observed using the transit method, at just about 3 million years old. This discovery was spearheaded by Madison Barber, a graduate student from the University of North Carolina at Chapel Hill, utilizing data from NASA's Transiting Exoplanet Survey satellite, known as TESS. IRAS-04125+2902b orbits a star located approximately 520 light-years away in the Taurus constellation, within a protoplanetary disk that indicates the star's youth. The planet, nicknamed TIDYE-1b, has an orbital period of 8.83 Earth days and boasts a radius about 10.7 times that of Earth, with a mass equivalent to 30% of Jupiter's. Its mass and size suggest a relatively low density and possibly an inflated atmosphere, characteristics commonly associated with young planets. This discovery offers essential insights into the early stages of planet formation, establishing a new benchmark for understanding young transiting planets beyond our solar system. The planet was detected due to a unique alignment of its protoplanetary disk, which is misaligned with the star's orbital plane, facilitating easier observation. Initial hypotheses regarding the disk's warping pointed to potential gravitational influences from a companion star. However, this was ruled out as no such companion has been detected. The misalignment challenges existing models of planetary formation, which typically expect a flat arrangement of forming planets. Researchers speculate that IRAS-04125+2902b is unlikely to evolve into a gas giant like Jupiter, and may instead become a mini Neptune or super-Earth, types of planets often found in other solar systems. Barber highlighted that studying young transiting systems like TIDYE-1b enhances our understanding of planetary formation and evolution, shedding light on the history of Earth. The findings were published in the journal Nature on November 20th, 2024, marking a significant advancement in the field of exoplanet research. A recent study from the University of Texas MD Anderson Cancer Center has uncovered surprising insights into the genetic makeup of normal breast cells in healthy women. This research challenges established beliefs regarding the genetic origins of breast cancer by revealing that these normal cells may exhibit chromosome abnormalities typically associated with invasive breast cancer. The study involved an analysis of breast tissue samples from 49 healthy women undergoing breast reduction surgery. This approach allowed researchers to directly compare chromosomal changes in normal tissues with existing clinical breast cancer data. By utilizing advanced techniques such as single-cell sequencing and spatial mapping, the team focused on breast epithelial cells, which are believed to be precursors to cancer. The findings identified common chromosomal changes, including extra copies of chromosome 1q and losses of chromosomes 10q, 16q, and 22. These alterations are also found in invasive breast cancers and are linked to specific cancer-associated genes. Notably, the data indicated that aneuploid cells represented known cell lineages of the mammary gland, displaying distinct gene signatures related to estrogen receptor positivity and negativity. Significant correlations emerged between a woman's age and the frequency of aneuploid cells, suggesting that older women accumulate more cellular changes over time. Lead researcher Navin highlighted the need for further longitudinal studies to explore risk factors that could lead these aneuploid cells to become cancerous, indicating that the implications of these findings may extend beyond breast cancer. The study received substantial support from multiple institutions, including the National Cancer Institute and the American Cancer Society, underscoring the importance of institutional backing in cancer research. Building on previous work from the Human Breast Cell Atlas, which mapped over 714,000 cells to create a detailed genetic profile of normal breast tissue, this research revealed that a median of 3.19% of epithelial cells were aneuploid, with over 82.67% showing copy number changes typical of invasive breast cancers. While not everyone may have precancerous conditions, this study emphasizes the necessity for larger investigations to understand the broader implications for cancer development. Acknowledgments for the research can be found in the published study, reflecting the collaborative effort behind this significant scientific inquiry. Imagine a world where patients can swallow a capsule to receive their medication, eliminating the need for needles. Researchers have developed a groundbreaking drug delivery device inspired by squids, which allows for this innovative method of medication administration. The device utilizes jets to eject drugs into the tissue lining of the digestive tract, significantly enhancing drug delivery efficiency. This approach, detailed in a study published in the journal Nature, offers a stark contrast to traditional needles by allowing the microjet system to administer medication from a distance or at a slight angle, thereby improving patient comfort. These capsules are engineered to target various sections of the digestive tract, merging the convenience of oral delivery with the efficiency of deeper tissue penetration for optimal drug absorption. Animal testing has demonstrated that the device can effectively deliver insulin and other medications, achieving blood concentration levels comparable to those obtained through injections. Constructed from metal and plastic, the capsules pass through the digestive system and are excreted after drug delivery, minimizing risks associated with needle use. Future plans for this technology include further development and human testing, with backing from organizations like Novo Nordisk and the U.S. Advanced Research Projects Agency for Health. Experts, including Giovanni Traverso from MIT, highlight the potential of this technology to revolutionize treatment for conditions like diabetes by enabling the oral delivery of macromolecules. The device features two versions, one with a flat bottom for downward drug ejection and another tube-like version for targeted side delivery. This innovation addresses the common preference for pill medications over injections, potentially enhancing patient compliance and comfort in receiving necessary treatments. As the healthcare landscape continues to evolve, advancements like this in drug delivery could play a crucial role in making medications more accessible and user-friendly. A recent study has unveiled a previously unidentified compound in treated drinking water, raising significant concerns about public health. Researchers from the University of Arkansas, funded by the National Science Foundation and others, published their findings in the journal Science, identifying the chloranitramide anion. This compound was detected in concentrations as high as 100 micrograms per liter in some U.S. water systems that utilize inorganic chloramines for treatment. Alarmingly, these levels exceed regulatory limits for disinfection byproducts, prompting experts to call for further examination of its presence and potential health risks. While the exact toxicity of chloranitramide anion remains uncertain, estimates indicate that it is likely toxic. This has raised alarms among researchers and water quality experts, who stress the necessity of additional studies to fully understand the implications of this compound. Chloramine, which is often chosen over chlorine for water treatment, is preferred due to its lower production of regulated byproducts associated with health issues, including bladder cancer. However, the detection of chloronitramide anion in treated water highlights the complexity of water treatment processes and the potential for harmful chemical formation. Julian Ferry, the lead researcher, has dedicated over a decade to studying chloronitramide, emphasizing the importance of identifying harmful chemicals in our drinking water. The findings from this research will be crucial in guiding the Environmental Protection Agency's decisions regarding drinking water standards and the regulation of chloramines. Experts stress the need for water utilities to minimize exposure to potential contaminants and to remain informed about ongoing research developments. Understanding the formation pathways of harmful chemicals like chloronitramide is essential to mitigate health risks associated with drinking water. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.